Okay, so this is day 2 of area between a curve. And what I'm going to do is I'm just going to go through about 3, maybe 4 examples of doing, well, area between a curve, much like we did in our last lesson. There's going to be some different types of problems. It's going to be more so like right minus left problems as opposed to like top minus bottom problems. Okay. So we're going to start off with this warm-up here, and this warm-up's not even really a warm-up because it's more so a lesson because we haven't really done a problem like this, but I think it's a very good problem. You got one like this on your homework tonight. You got one like this on your weekly assignment, so we got to make sure we're all set. So let's read through it. Let's kind of set it up, kind of think about what's going on here. It says find a number b, okay, so find a number b such that the line y equals b, remember it was y equals, so it's horizontal, divides the region bounded by the curves y equals x squared and y equals 4 into 2 regions with equal area. All right, let's draw that out first. So I'm going to draw my graph. I'm going to draw it like this. And we're bounded by y equals 4. So here's 1, 2, 3, 4. This line here. Okay. And we're bounded by the curve x squared. So I'm going to graph those points. Over 1, up 1, over 2, up 4. Negative 1, up 1, negative 2, up 2. So there we go. All right. Now, so if I'm talking about the area bounded by this, I'm talking about the area from this shape right here that I'm going to outline in red. So it looks like this, right? I'm talking about this area here. Now, I'm trying to find some number b, and I'm going to take a kind of a guess. I don't know where it's at, but I'm going to try to find some number b that if I do y equals that, it's going to divide the region, all right, into 2 regions with equal area. So what I mean here is that like if I say like right, I don't know, right here, okay, if I let this line be y equals b, then it's going to partition this area into an equal area up here as it is down here, 2 equal areas. So let's think about that. I think a good place to start would be to figure out, well, what the heck is the area of the entire thing? Then we'll worry about partitioning it later. Okay? So first things first is I'm going to figure out the area between the curves, and that's something we did yesterday. So this is an integral, okay, from, we'll just say a to b of top minus bottom. We have a top function, and we're going to subtract a bottom function um, in terms of x here, okay? So let's think about, okay, what our intersections are. So what intersections is these two functions crossing at? Well, you can probably already tell, but that's just as simple as setting the two functions equal to each other and solving. And in this case, we get plus or minus 2. So we're going from negative 2 to 2, okay? And we're doing our top function, which is y equals 4, subtract our bottom function, which is x squared, okay? So solving this exact area right here will tell me the area between the two curves, okay? Um, Now, I don't know how much I went into detail with this yesterday, but something I want to clarify is this area right here of this function, it's symmetric about the y-axis, meaning that the area from negative 2 all the way to 0 is equivalent from 0 all the way to 2. So wouldn't you agree that this integral right here that I just set up is equivalent to 2 times the integral from 0 to 2? Can I not just double half of this area from here to the right? Because it's symmetric, so those areas are going to match up. This happens a lot when we're taking the area under the curve. We have a lot of times polynomials that are symmetric about the y-axis, so we can just double half of it right there. Okay, so let's keep that in mind. And trust me, it's a lot better to evaluate at 0 than at negative 2. So I think that's a very helpful step to take. And that happens a lot. So anyway, we got 2 times the integral 0 to 2 of 4 minus x squared dx. So let's go ahead and figure out what this area is, and then we'll go from there. Okay. So just doing a quick little math here. That's going to be 2 times 4x minus 1/3 x cubed, and we're evaluating from 0 to 2. All right. Well, so just plug in our values here. We got 2 times. That's 4 times 2 minus 1/3 times 2 cubed minus, and plugging 0 into that's just 0. So this ends up simplifying down to, and you can do the math yourself or just trust me on it, but it simplifies down to, this simplifies down to 32, 32 over 3. Okay? So what we just did is we found the area underneath the curve. Okay, nothing too much, nothing too bad. Okay, so what I'm trying to figure out is how can I figure out a y value, all right, a y value that whenever I go to this point, and I'm going to trace this in blue here, I'm trying to find a y value that whenever I do y equals that, all right, it's gonna crush this into 2 sections of equal value. Okay. Well, whatever this y value is, it's not going to be too bad. All you got to do is just set up an integral and solve for it. Okay, so let's think of it this way. I want to figure out an interval from this value to this value that when I take this area right here is going to be equal to half of the area of the whole thing. Then I'll find that y value that partitions it. Okay. So basically, what I'm talking about is let's first figure out like where this intersection is in terms of b. I think that's a good place to start. Okay. So just as before, I'm going to set x squared equal to that new y value. It's not 4 anymore, it's b. So my interval is x equals plus or minus the square root of b. So this is basically what I'm saying. How I solve this problem is not too bad. All I'm saying is that the integral from now, instead of -2 to 2, it's negative square root of b to square root of b, right? When you agree? If I do the integral of that of um, my b function, which in this case is just b, my top function minus my bottom function, which is just the function x squared, if I take the integral of this, I want it to be equal to half of this. Well, half of that is just 16 over 3. So if I can solve for that, then I'll have b, and it's not too bad. So do we see how this right here, and you see why I did b minus x squared, because now the top function is just y equals b, and the bottom function is x squared. No longer is 4 even in this equation. Okay? So now when I do this, I'm going to do the same logic as I did before. Because this is symmetric right here, negative square root of b to positive square root of b, I can say this is 2 times the integral from 0 to square root of b minus x squared is equal to 16/3. And I can divide both sides by 2. So if I divide both sides by 2, I'm left with the integral 0 to square root of b minus x squared dx equals 16/3 divided by 2 is 8/3. So now I'm just going to take the integral and plug in the values and solve for b, which isn't too bad. All right, b is just a constant, so the integral of b is just bx, and then minus 1/3 x squared, and we're evaluating from 0 to square root of b. Okay, and again, this is going to equal 8/3. So now I'm going to plug in my values. So b times the square root of b minus 1/3 square root of b squared. And if I plug 0 into any of that stuff, it's just going to be 0, and that equals 8/3. Okay? Let's keep going. We got this. We can keep going. So what is b times the square root of b? Well, that's b times b to the 1/2, and all you do is just add those powers together. It's going to be b to the 3/2 minus b squared. Square root of b squared is just b, so 1/3 b, and that's going to equal 8/3. Oh boy. And after just looking over this problem, I realized that I messed up in one spot. That the integral of x squared is 1/3 x cubed, which I don't know why I didn't see that until just now. But so that should be a cube right here, and instead of just b right here, this is now um, 1/3 uh, square root of b to the third power would be then b to the 3/2. Okay, so now it becomes a lot easier of a problem to solve. I apologize for the mistake there, but it still looks scary, but it's not too bad. Notice how they have a GCF of b to the 3/2 I can take out. So I got b to the 3/2 I can take out, and I'm left with 1 minus a third equals 8/3. Okay. Well, just keep going with it. You got this. This becomes b to the 3/2 times 2/3 equals 8/3. B to the 3/2 equals 8/3 divided by 2/3 would be 24 over 6, or just 4. Nice. Okay. So then how the heck do you figure out b to the 3/2 equals 4? Well, then you could just do b to the 2/3 power, okay, which I'm going to do, that crosses that out, and then I got b equals whatever 4 to the 2/3 power is. And, I mean, what's that, the cube root of 16? It's not going to be a pretty number, so I'm okay with you just leaving it like that. So that is the y value, 4 to the 2/3 power. Okay, y equals 4 to the 2/3 power. That's the y value that's going to partition this into two areas of equal value, which I thought that was a pretty fun problem. But anyway, you have a couple problems like that on your homework and on your weekly assignment. So just remember that the steps for this is to pretty much just figure out your area. So find total area. And then step 2 is to pretty much set up an integral. Set up integral that equals half the area. Okay, and usually you have to solve for one of those intervals, and there's a number of ways to do it depending on the problem, but it usually follows pretty procedural steps, kind of like that, and you should be able to find it. Okay. All right. So that's the first kind of warm-up problem, which I thought was just a good one to practice. I thought it was just a good problem to practice finding that value that splits it in half. And if we have time, I'll probably do another example later on in the video. Okay. But the next example, which may be different than the one on your warm-up, but I really want to practice another one finding the average value, and then we'll move on to new stuff. And if you want to skip forward through this to the next part, you can, but I just want to make sure we're still good on finding the average value. And again, that was 1 over b minus a. In this case, that would be 7 minus 1 is 6. And we're doing the integral from the function x squared minus 5x plus 7 over 2x. And I'm going to go ahead and simplify that down by dividing everything by 2x. So it's going to be 1/2 x minus 5 halves plus 7 over 2x to the negative first. Okay, dx. Okay. So if I integrate that, that's just going to be 1/6. All right, and the integration of 1/2 x is going to be plus 1 is 2, so it's going to be 1/4 x squared minus 5/2 x plus, and I know I wrote this x to the negative 1, but that's really 1 over x, which is natural log, so 7/2 ln absolute value of x and we're going from 1 to 7. Okay, so that's all average value is, and I'll let you plug 7 in. I'll let you plug 1 in, and honestly, I wouldn't expect you to simplify it much further past that point. But hopefully, we feel good with average value. Okay. Okay, so now technically the new stuff for today. I only got 2 examples that I want to do with you, and when I go through these 2 examples, they're going to be really similar to the ones from yesterday, but they're just set up a little bit differently. Okay, so there's the ones we talked about yesterday were top minus bottom, and the ones we're talking about today is right minus left functions. This is whenever you don't have explicitly a a function that is always on top versus always on bottom. And here you can even see, like, here's the intersections. You have no top function. This function right here is not really always on. It's only on top from like right here. It doesn't really work out to do a top minus bottom function. Okay, so in this problem we have to set up the integral a little bit differently. Okay, and how I like to think about it is if you tilt your head a little bit, it looks like a top minus bottom, but in this case we're going to do a right function. Okay, subtract a left function. Okay, so a right function subtract a left function here. Okay, so if you're going to be doing right minus left, then that means instead of having y equals equations, we got to have x equal equations. Okay, x equals equations, and that means that our interval, instead of being x bounds, are going to have to be y bounds. They're going to have to be y values. We're pretty much swapping everything out to make it left or right minus left, making it all in terms of y instead of x. Okay. All right. Now, just for preface this a little bit, this is going to be a calc active problem. So this is going to be active problem just to help us out. Okay. All right. So just to write this all out again, this is a right minus left problem. Okay. This means that like my functions are actually going to be perpendicular to our y-axis. Okay. Instead of my x-axis. All right. So therefore, we're going to have to use our variable y. Okay, so that means we got to get x in terms of y. So no longer are we going to have a y equals, we're going to have an x equals. Okay, so that means that we're also going to have y bounds. So like I said earlier. Okay, so our integral is going to be the a to b, and these are going to be, again, like I said, y values. And it's going to be a right function minus a left function, and it's going to be dy instead of dx. Okay? So, let's go through with this. Oh, I just realized that I never paused the video. Okay, cool. Let's keep going. That's fun. Okay. Anywho, I wonder how long that awkward silence was. Okay, cool. So anyway, in this problem, we can probably definitely see which one's the right function. Okay, it's going to be this linear equation, and we can probably see what the left function is here, and that's going to be my y squared equation. Now, because this is all in terms of y, I need to have 2 x equals equations to plug in for my r and my left instead of y equals equations. So let's remember that the first equation was y equals 3x minus 4, and the second equation was y squared equals x plus 4. I need to get both of those in terms of x equals to plug into my integral, right? So like in this case, like The first one, it would be, let's see, so that would be x equals 1/3, um, 1/3 y plus 4/3. And my other one in terms of x would be x equals y squared minus 4. Okay? So we can probably tell from the diagram up there, the graph, that the linear equation, this is my right function. This is the one that's always to the right. And my left function is the quadratic. Okay? So if I'm setting up my integral, it's the integral from a to b, and we'll talk about the intersections in a sec, of my right function, which is that 1/3 y plus 4/3, minus my left equation, which is that y squared minus 4 dy. Okay. Now, the only other thing I need to get is my a and my b. Well, that's the intersection, and that's the intersection in terms of y. So all you have to do is set the equations equal to each other and solve for y. So I can literally just set this equal to this. All right. And then I can solve from there. So let's go ahead and do that. Um, that is 1/3 y plus 4/3 equals y squared minus 4. And we're going to solve for y. And this is the reason why I made it calc active, because that doesn't end up being a pretty little thing. I'll tell you why. I mean, initially I went ahead and like multiplied everything by 3. I was like, let's go ahead and multiply everything by 3 just to get rid of those fractions. So I got like y plus 4 equals 3y squared minus 12. And then if I got everything to one side, that's simplified to 3y squared minus y minus 16 equals 0. But the only problem is like that doesn't factor. So all I did was plug that in the calculator and found those intersections. So I found what the two y values were from that graph. So I plugged this in the calculator, looked for where it crossed 0. I could have done quadratic formula if I really wanted to, but in this case, y equals, I got negative 2.149 for this first one, and for the second one, I got, let's see, 2.482, and those seem like reasonable values for what's up here. I mean, here's the negative 2 point something, and here's the positive 2 point something. It looks about right. Okay. So, um, finding those intersections, that makes my interval, the interval from negative 2.149 to 2.482 of my right function, which is 1/3 y plus 4/3 minus my left function, which is y squared minus 4. And I literally typed this in the calculator in my interval. And what I got to be was, I got 16.551 approximately. And again, I just typed this in exactly like I did in the calculator. It's okay in the calculator. Like I made my y's x's. Like that's okay. You don't have to like make it like y in the calculator. If you put it as x's, it'll do it for you the same way. So again, that 16.511 was this area right here. So yay. The only thing different in today's lesson from yesterday is that we just have to make sure we change everything in terms of y. Like we got to get that intersection in terms of y, and we have to get our equations in terms of y, which isn't too bad, I don't think. It's just manipulating some stuff. Okay. Okay, so this is the last example in your notes, but honestly, I mean, I might do a couple examples from your homework. So after this example, you're welcome to like stop watching and begin your homework, but just for helping y'all out a little bit, I got a couple more problems from the homework that might just help you get started, and so you don't have to do as much. Especially there's like I got one problem I was going to do that involved like finding the line that bisects the area, so I figured that could help a little bit. But anywho, let's talk about this last one. Okay, so it says find the area enclosed by the line y equals x minus 1 and y squared equals 2x plus 6. If you ever have a y squared equation, okay, think about what happens if you get y by itself. That's y equals plus or minus the square root of 2x plus 6. Okay, and if you ever run into that case, if you have a y squared, the plus and the minus, that means that the y equals is not really a function, okay? You've probably learned and seen by now that the y squared implies that we have a sideways parabola, right? Like think about it. The positive square root is doing this. The negative square root is doing this, okay? So you probably learned that back in your parabola unit way back when, but again, if you ever come across a y squared, and it was just like the same one in the last example, it's a sideways parabola. This means that we're going to have to be doing some right minus left. And if you're curious again about what this shape looks like, go ahead and graph this in the calculator if you want as two separate functions. But the graph ends up looking like this. Okay? The graph ends up looking like this. And if I graph the line y equals x minus 1, so that's like right here, the function looks something like this. Okay? So this is what my graph looks like. And I'm not always going to expect you to graph it or look at it to see what we're dealing with. You're just going to have to recognize which one has to be the right function, which one has to be the left function based off of the type of function we have. Okay? Like for instance, if this was like a negative x value, it would be a flipped parabola. And then the parabola would end up being my right function, and the linear would be my left function. Okay? So we'll practice more about recognizing that. But right now, let's just worry about setting it up and going through solving. Okay? All right, so again, this is the interval a to b of a right function minus a left function because of how it's set up, dy. Okay? Notice how there is no top and bottom. There's only a function that is always to the right and a function that's always to the left. So we're finding this area right here. All right, well, we already know what my right function and my left function is. My right function is that line, and remember that it has to be in terms of y, so we have to get it as x equals. So in this case here, this function is x equals y plus 1, and the function over here to the left, the parabola, is x equals, you can do the math if you want, that looks like 1/2 y squared minus 3. Okay, so my right function is that line, so that's y plus 1, subtract, and my left function is 1/2 y squared minus 3 dy. Okay. Now, the only other thing we have to figure out is those intersections. So we're going to set those two equal to each other, or really another thing you could do is just like you could set them equal, which is fine. You could do 1/2 y squared plus 3 equals y plus 1 and solve. Or sometimes what's easier is just taking this y plus 1 and substituting it in for x and just solving. Like something that might have been easier would have been to say that like y squared equals 2 times y plus 1 and then plus 6. So that's substitution. So this is just setting them equal to each other. This is doing substitution. It equates out to the same dang thing. All right, so it's up to you kind of how you want to do it. All right. But anyway, I'm just going to kind of go along the lines more so with this one, so the second part. So I'm going to say that y squared equals 2y plus 2 plus 6. Okay. And then just getting everything to one side. We got y squared minus 2y minus 8 equals 0. Unfortunately, in this one, it does factor, so I don't have to worry about doing this in the calculator. This would be more so of a calculator inactive problem. The factors of -8 add to -2, isn't that just y minus 4, y plus 2? They multiply to -8 and they add to -2. So my intersection points are at y equals 4 and -2. So that's the integral, -2 to 4 of y plus 1 minus 1 half y squared minus 3 dy. So this is the correct setup. We got everything in terms of y. We got y bounds and a right minus left. So let's go ahead and solve that out. And let's get our final answer. And we'll do this by hand. Why not? So just rewriting it, I got negative 2 to 4. Wouldn't that just be negative 1 half y squared plus y? And then I'm going to combine 1 minus negative 3 or plus positive. Wouldn't that just be plus 4? You can check my math on that. I'm going to take a second and make sure I did that right. Minus 1 half plus y, and then plus 4. Okay, so let's integrate and solve. Let's see what we get. Negative 1 half. Oh, sorry. If I were to integrate this, that's going to be negative 1 half times 1/3 y cubed plus 1 half y squared plus 4y, all evaluated from negative 2 to 4. And so that's what? Negative 1/6 4 cubed plus 1 half 4 squared plus 4 times 4 minus, and then everything with a 2 plugged in. So negative 1/6 2 cubed plus 1 half, negative 2, I apologize. Negative 2 squared plus 4 times negative 2. And I will let you solve that one out, but what I ended up getting was equal to 18. All right, great. So that does it for like all the new notes and stuff. So again, the only difference between this and yesterday was getting it in terms of y. And now if you want to stop and start working on the worksheet, you're more than welcome to, but if you want to keep listening, all right, I'm going to go through and do I'll do 3 problems from the homework. So I'm going to do these 2, and I'm going to do these 3. Or, yeah, these 2. Okay? And then, you know, you can do the rest on your own or just try it all by yourself. I don't care. Answer key's already uploaded online. It says in exercises 21 through 22, find the area between the graphs of y equals sine and 1 minus cosine y over the given intervals. Notice it's both x equals, okay? And you can even see the graph given right here. This is your 1 minus your cosine of y, and this right here is sine of y, okay? Notice how you don't have any top minus bottom functions. You have a right minus a left, okay? Now in this case, I actually am curious. This red does look to always be on top, maybe? But again, you have x equals equations, so your best option is to do a right minus left, okay? So let's figure it out. Here it says that we're doing it from 0 to pi over 2. 0 to pi over 2. Nice. Well, that's not too bad. So I got my bounds. It's already giving me my y bounds. I don't need to worry about finding an intersection here. That's saying, hey, let's do the integral from 0 to pi over 2 of my right function, which in this case is 1 minus cosine of y. Subtract my left function, which is just sine of y. And I realize now that I just wrote it, that my right function was actually sine of y. So let me refresh that real fast. My right function, which is this function right here, that's sine of y, minus my left function, which is 1 minus cosine of y. Yikes. dy. Okay? So let's try to do that by hand if we can. All right, let's integrate each piece. So the integration of sine is negative cosine of y. That's going to be minus, okay, the integration of 1 is just y. and then it's going to be plus cosine y. So the integration of cosine y is going to be just sine of y. Okay? And we're doing that from 0 to pi over 2. And again, I distributed the negative before I took the integral. Okay. Okay. So plug everything in. So we got the negative cosine of pi over 2 minus pi over 2 plus the sine of pi over 2. Okay. All that minus the negative cosine of 0 minus 0 plus the sine of 0. Okay. We'll just simplify down each piece. The cosine of pi over 2 is 0 minus pi over 2 plus the sine of pi over 2 is 1. So I got 1 minus pi over 2 minus, and then the, let's see, the cosine of 0 is, what's the cosine of 0? That would be 1, so negative 1, minus 0, and then the sine of 0 is 0. Okay, oops. So finally my answer will be 1 minus pi over 2 plus 1, or 2 minus pi over 2. All right. Okie doke. Let's try the next one. Next one is the same exact dang thing, but we are doing it from negative pi over 2 to pi over 2. All right, let's think about this. Okay, let's look at this. So, from negative pi over 2 to pi over 2. Okay. Well, negative pi over 2 to pi over. Here's negative pi over 2. And I'm going to go all the way up to pi over 2. Okay? So let's think about this. If I'm going from negative pi over 2 to pi over 2, is the sine of y, is it always my right function? No. It soon transitions into my left function once it reaches a certain y value. Okay? And that y value ends up being right here at the intersection of y equals 0. That's because if I were to set sine of y equal to 1 minus cosine of y, it's at y equals 0 that makes those equal. Okay? So in this case, the sine function is only the right function whenever we are from 0 to pi over 2. So it's the integral from 0 to pi over 2, okay, of my right function sine of y minus my left function 1 minus cosine of y dy. But then, as I go from negative pi over 2 to pi over 2, okay, or I'm sorry, negative pi over 2 to 0, I have a different set of right and left functions. So between these values, right here, my right function is 1 minus cosine of y. So it basically switches 1 minus cosine of y, and then minus my left function now, which is sine of y. Okay. So we had to split it up because there's a change in the right versus the left function, and this is how it looks. So I'm going to kind of go down here and solve this. Well, I already know what that's equal to, don't I? I mean, if you look over here, it's just the same as the area we found previously. So I know that's going to be 2 minus pi over 2 plus, and now the integral from negative pi over 2 to 0 of 1 minus cosine of y minus sine of y. Okay, so let's go through and solve that piece out real quick. Okay, so let's see here. I'm doing this quantity plus this. This would be 2 minus pi over 2 plus the integral of 1 would be y. The integral of negative cosine is going to be negative sine of y, and the integration of negative sine of y is going to be, let's see here, positive cosine of y. And we're evaluating from negative pi over 2 to 0. Let's do that real quick. That's 0 minus the sine of 0 plus cosine of 0 minus negative pi over 2 minus the sine of negative pi over 2 plus the cosine of negative pi over 2. So just to keep going, that's 2 minus pi over 2 plus the 0. Okay, so sine of 0 is 0. The cosine of 0 is 1. And that's minus, so that's negative pi over 2. And then the sine of negative pi over 2, wouldn't that just be negative 1? And then plus the cosine of negative pi over 2 would just be 0. So what I'm seeing here is that we have 1 minus 1, so this 1 minus 1 goes to 0, and I have all of this becomes just positive pi over 2, and I have 2 minus pi over 2 plus that, so I'm left with just 2 as my final answer. So that's a good problem, but my suggestion was just to recognize that you had a switch in the right to left function. So you couldn't just do the same setup as you did in 21. You had to think about that break. Okay. And the last one I'm going to do is one that was on the back of the homework. It's just a free response question that I have done. So let's look at part A. It says, let R be the shaded region bounded by the graphs of y equals square root of x and y equals e to the negative 3x. I think that we can distinguish between this graph and this graph without graphing, hopefully. This is an exponential decay right here. We know what the square root of x looks like. This is the square root of x function. So this right here is my top, and this one right here is my bottom. Notice I'm not doing left minus right anymore, because this function is always on top and this function is always on bottom. No need for a right minus a left. We can just keep this all in terms of top minus a bottom. Okay? So, anyway, we got that, and it's bounded at the intersection of the two, and x equals 1. Okay? So first of all, it says find the area of R. So first of all, if I want to do that, I need to know my interval here. So I know that it's going as far as 1, but I need to figure out this intersection here. Since I'm back to top minus bottom, it needs to be in terms of x. So what I did is I did the square root of x equals e to the negative 3x. And honestly, I did that in the calculator, and I just solved for x real quick. The value I got was 0.2387341. And honestly, guys, in my calculator, you don't have to do this. You can just do like 4 decimal places if you want. But I stored that in for x. And in the context of this problem, I'm going to classify this as my variable a. And you can do that on the final exam if you want. Just make sure you always stick with a equaling that and never try to use that variable twice. But in this case, it's just going to be the integral from my lower bound, which this intersection I said was at point A. So A, and which really means 0.2387. I'm doing that in the calculator. All the way up to my bound of 1. So I'm going to find the area between those two values. And my top function, I said, was the square root of x. And my bottom function was e to the, negative 3x power. Okay. Dx. And honestly, guys, again, I just typed that in the calculator. And what I got was, because this was calc active, was 0.44, 426. Here's the part I really wanted to get to. It says there is a value x equals k, okay, that bisects the area of the region R, and I want to find that value. So I'm saying there's some x equals k value. that's going to make it to where this area is equivalent to this area here. What the heck is that value going to be? So basically, all I have to do, all right, and this isn't too bad at all, is set up another integral that's going to solve for that. If it bisects it, it means it's going to be equal to half the area. Well, what is this area divided by 2? That's what, 0.2213? Okay, so I'm trying to set up an interval or an area, integral that's going to equal that, that has k in it, that I can solve for it. Okay, well, how about this? I can either choose to go from a to k or k to 1. If I had an option between my decimal a and my other bound 1, I'm going to choose the easier one, 1. So I'm going to say, hey, the interval from k to 1, so I know that's going to equal half my area of my top function, square root of x, minus my bottom function, e to the negative 3x dx. All right, there you go. There's your equation that we can set up and solve. So let's integrate this bad boy and solve. So integration of square root of x is 2/3 x to the 3/2. If I'm integrating this bad boy right here, I could do u sub, but remember that the negative 3 comes out as negative 1/3, so that's going to be positive 1/3 e to the negative 3x. Okay, and I'm evaluating this from k to 1, and that's going to equal 0.2213. So I'm just going to plug in values and solve. So I'm plug 1 in for x. That's 2/3 1 to the 3/2 plus 1/3 e to the negative 3 times 1 minus 2/3 k to the 3/2 plus 1/3 e to the negative 3k. I plug it in, right? Yeah, plug in k for, yeah, there you go. And then that's going to equal 0.2213. And honestly, guys, I plugged this crap into the calculator and I solved the bad boy out. Basically what I'm saying is I plugged this into y1, this into y2, and I found the intersections. If you want to tidy it up a little bit, you can. You can say this is 2/3 plus 1/3 e to the negative 3 minus 2/3. Now I'm solving for an intersection here, so instead of k, I keep k on the paper, but I plugged in x for my calculator's sake, and I just solved this bad boy out. And when I did the intersection in the calculator, what I got was 0.7418. Yeah, that's what I got. All right, so hopefully that helped you clarify a little bit of that bisecting stuff. You will have a problem like this on your weekly assignment. Good luck, you guys got this. Y'all are awesome little angels. I want you to know that I freaking enjoy this. Oh, I hope you did too. I'm trying to go to 48 minutes, or 49 exactly, so just bear with me here. OCD purposes. 4, 3, 2. Okay, bye. Good luck.